associated with this explicit equation information. And an explicit formula is not recursive, and it has x and y's, so it's not recursive, which means it allows you to jump to any specific value. So for example, we're talking about equations like y equals 3x minus 7. That's an explicit equation. A linear equation is one that we just got done talking about. The general way that we usually write linear equations, you might have seen them like y equals mx plus b. That's in slope-intercept form, where the m is the slope, the b is the y-intercept. Our calculator will also use y equals a plus bx if you want. So when you look at equations in there and you do regression equations, this is one of the forms that they'll have, where the a is the y-intercept and the b is the slope. So if that helps, maybe we should write that down. So the slope is the m right here and the b right here. And the other things that we talked about were the y-intercepts. So the y-intercepts are the a in this case, or the b in this case, which is a little bit confusing if you think about it, because they use b in both equations, but it just depends on how you set it up. So the thing that's with the x is the slope. The thing not with the x is the y-intercept. Slope is a rate of change. So when you're talking about slope, this is a rate of change. You might have heard it as delta y over delta x. Sometimes we talk about it as the rise over the run. And the formula that we've also talked about is y2 minus y1 over x2 minus x1. Earlier. So collinear just means that things are on the same line. That's all it means when you say that they're collinear. And then we're talking about points, of course, that are on the same line. And discrete means that we're talking about points that are not connected. So in a line, what happens is all the points that are collinear are connected. But in a discrete set of points, like a scatter plot, we talked about that, I think, earlier. If you had a scatter plot, and we look at these points, these are not connected. It's a bunch of information, data. We don't connect them with a line. We look at the data itself. And those are discrete points. Questions on any of these vocabulary items? All right, so in this think about it problem, oftentimes in math, they'll like to give us a table. And from that table, glean some information about how we're going to write something down. So we see this table where there's some time and days, and there's a height, and a gardener has planted a new variety of grass and is keeping a record of how high it grows. And most cities, like I live in Hopkins, most cities have an ordinance that if it gets so high you have to cut it, otherwise you can get a ticket. So they want us to come up with a recursive formula that predicts the height after 21 days. So like you could probably figure out how it's jumping and do that, or like we've talked about earlier, math people like to find a rule, and then you can figure out anything from the rule. So one of the ways that you can do that, we need two things, of course. We need its starting value. I see its starting value down here, so this is good. So this is talking about, of course, u0 and we know that the U0 is 4.2. So that's good. But then kind of the big idea is to understand how it's jumping. Now most tables that we've worked with go 0, 1, 2, 3, 4. Some tables don't jump like that. Notice this one jumped 3 units, then 4, then 3, then 4. It's not jumping by the same amount. So you have to be careful. So to find out how much it's jumping by for every 1 unit, what you do is you take the amount it changed in the y value, so this change right here. So 6.3 minus 4.2 is it jumped 2.1 centimeters. And then you also look at the jump that it made in days. So we just talked a little bit ago about slope, which was the rise or the run or the change in the y over the change in the x. This is the change in the y. If I divide that by the change in the x, which was 3 days, this will give me my rate of change. How fast am I changing? So if you calculate that, you will find out that it's changing 0.7 centimeters every day. Or in other words, this is how much it grows daily. So if it went 2.1 centimeters for 3 days, then each day it's going up by 0.7. You could actually take any other set. You could take the very first one and the very last one, and the same with the first and the last from the table, and find the same amount. It doesn't matter which 2 you pick as long as you pick the same 2. So I picked this set of data and this set of data in order to work it out. So the 6.3 minus the 4.2 and the 3 minus the 0. That's what I did. You could have picked any 2 points. It doesn't matter to find the slope. Now once I have this 0.7, this is my rate that I'm increasing each time. I'm adding on 0.7 to get every next day. So if I wanted a recursive formula, what I would do is I would say I'm starting at the very beginning, times 0, and the height of my grass is 4.2 centimeters. And then if I want to know what happens from then on, my un is un minus 1 plus 0.7. Or in other words, I'm going up by 0.7 centimeters daily. And if I'm looking at y equals, instead of writing it the way that you see in red, what I could have done is this. Y equals 0.7x plus 4.2. Notice that my starting value is the same as my y-intercept. And also notice that my increase is the same as my slope. That's kind of the big idea for today. This is the most important concept. That when we've been working with recursive formulas, whatever you start at, that's your y-intercept. Whatever you're increasing by or decreasing by, that's your slope. So if you get recursive formulas, you can always change them into explicit formulas. Questions about that? Okay, so when we're looking for the explicit equation, remember we're always in y equals at that point. And the number that goes in front of the x is whatever your increase is by. So in the recursive equation, I notice that it says plus 3. That means I'm going to have 3x. And the starting value is 5, so I go with plus 5. And again, when we're matching things up, my y-intercept is whatever the starting value is, and my slope is what I'm going up by. The second part to this is find U15. And basically what this means is you're plugging in the 15 for x. So really, U15 is saying that your y value would be 3 times, now plug in that 15, and then add on 5. And when you do that, you find out that you get 50. So the U15 is only telling me when I see that 15 that I'm shoving in the 15 for the x value. That's what it means. And then the last thing is find out the value. So un is 68. really what that's telling me, and it looks kind of confusing the way they say it, is really they're telling us that un is our y. So they're saying, hey, the 68 is the thing I want to have happen, and that's equal to 3 times x plus 5. And you're trying to find out what is this x value that's going to make that happen. And again, you could, like Fiore said, go into your table, scroll down till you see 68, and then look across to the x value and find that value. But this is the algebraic way to solve it. And this is the beginning course for upper level algebra stuff. So like next year if you take Intro to Pre-Calc or Pre-Calc, you're going to do a ton of stuff without a calculator. 1/3 of your exams are without a calculator. So in this particular case, I'm going to move the 5 to the left-hand side. Remember that when I move things, they change sign. So the 5 that was positive on the right becomes negative on the left. So now I'll have 63, because I minused 5 from both sides, is equal to 3x. And then, of course, I would have to divide both sides by the 3. So 63 divided by 3 is 21. So my x value is 21. Again, you could look in your calculator. You're always allowed to use calculators in this class. In this next slide, we're going to do both. We're going to try to be familiar with going back and forth. So you've got a Caribou